Okay, so let's look at process BC, which is an isochoric heating. So we're not allowing the piston to move, we're just adding heat to this to raise it from whatever this temperature is to whatever this temperature is, right? Now, of course, we know that this temperature is 896.3, and we know this temperature is, 298.8 roughly, right? Okay. And so here's the thing, right, is we know that the work done by that process is zero. Here's why. The change in volume is zero, and work is pressure change in volume. If that's zero, then this is zero, okay? So we know that there's zero work, so this guy's zero. And all we have to do is figure out the change in internal energy, right? And that'll be the same as the heat that flowed in. So basically, this is just a closed container. We don't allow the piston to move. We pump heat into it, and the pressure rises, okay? We're familiar with this. We've all tried to microwave a container with the lid on it, right? The pressure increases, okay? So to find the change in internal energy, there's two different ways to do this. I'll show you both. You could just use this, since we know the temperatures, right? That the change in internal energy is 3/2 NR change in temperature, right? So it's going to be 3/2. N is 1.45. We know that from previously. It's not on this page, but 8.31. And then our change in temperature is 893 or 896.3 minus 298.8. Right? I'm just going to use so if you get slightly different, I'm going to use the values that are on my calculator. So 3 divided by 2 times 1.45 times 8.31 times left parenthesis, the final temperature. And this is always final minus initial, right? Final minus initial. And this ends up being exactly 10,800 joules, okay? It's a positive number, right? Because this is the final temperature. It ends up hotter, right? Okay. Now, you know, it's like, that's very suspiciously even, whereas these numbers were terribly uneven. So how's that possible? And the answer is that the shortcut for this is delta U is 3/2. In this case, it's change in pressure times volume. So if only the pressure or only the volume changes, remember that PV is nRT, right? So if just one of those changes, we can use this, okay? So 3/2, delta P is 12E5 minus 4E5. And then the volume is 9 times 10 to the minus third. Okay, so let's do this. Let's see if this works. 3 divided by 2. If it doesn't work, by the way, we will have discovered the eternal flaw of physics. Either that or I'm a spaz, you know. Okay, so that minus 4E5. So 12E5 minus 4E5 times 9E minus 3. Oh, lo and behold, I get the same answer, okay? So remember that, you know, the IB test is timed. You don't have all day. Certainly don't do it both ways, unless you have the time to check your work, right? I would do this way, okay? So now the question is, okay, so that's our change in internal energy, right? So it's 10,800. And remember that Q is equal to delta U plus the work we do. Work is 0. So what plus 0, or 10,800 plus 0 is 10,800. So I'm using this formula, right? This we figured out was 10,800. Because the piston didn't move, that's 0. So therefore this is 10,800. That's the devilry that's going on here. All right.